Light is an electromagnetic wave and has electrical and magnetic properties, and the wavelength and frequency of light are related to each other. Light is the basis of all visual experiences, including the color we see, and is also the basis of optical technology. Since light is an electromagnetic wave, it is composed of vibrating electric and magnetic fields, and these electromagnetic fields vibrate at regular intervals to create waves. The period of this wave is called wavelength, and there are various wavelengths of light. The wavelength of visible light is usually between 400 and 700 nanometers, nm, and the color varies depending on this wavelength. Light is also very fast. The speed of light is about 300,000 kilometers per second, and it can travel the distance between the Earth and the Moon in 1 second. At this rate, light illuminates everything we see, and determines the color and shape of the object we see. Light also plays a very important role in our daily lives. For example, light from the sun produces vitamin D that we need to survive, and light as an electromagnetic wave is also used for communication and wireless communication. Einstein's theory of light is a theory of relativity, arguing that the speed of light is constant for all observers. This theory is based on denying the assumption that space-time is absolute, which was previously assumed in Newton's theory of motion, and replacing it with a relative concept. To give a theoretical example, when a person in a spacecraft looks at Earth, his or her time goes slower than we see it. Also, when a person generates light, the speed of the light remains constant even in a spacecraft moving with the person. However, people who observe the light from outside the spacecraft are observed to slow down the speed of the light. In other words, Einstein proposed a theory of relativity that deals with the movement of light based on the fact that the speed of light is constant for all observers, which was a very innovative theory. This has greatly developed an understanding of the structure of the universe and the technology we use light, and is one of the important concepts that lay the foundation of modern physics. Light is known to have both particle and wave properties. The wave nature of light means that light propagates in the form of electromagnetic waves. The characteristics of the wave are wavelength, period, amplitude, etc. The wave nature of light is very important in explaining the phenomena of light scattering, refraction, interference, and polarization. On the other hand, the particle nature of light means that light has properties as a particle. These particles are called photons, and they have mass and charge. The particulate nature of light plays an important role in explaining the absorption, emission, and photoelectric effects of light. Thus, light has both wave and particle properties, and this duality has led to much discussion to this day regarding the development of quantum mechanics. A photon is a minimum unit of electromagnetic waves more than atoms that make up electromagnetic radiation, a kind of electromagnetic wave. Photons are one of the prime examples of the duality of electromagnetic waves and particles in quantum mechanics. Photons have both wave properties as electromagnetic waves and particle properties as particles. As an electromagnetic wave, photons can appear in wavelength and amplitude, and as particles, photons have no mass and charge. Photons are the basic particles that make up light. Light or electromagnetic waves are made up of successive generations of photons. In addition, photons interact with electromagnetic waves to generate optical phenomena such as refraction, reflection, transmission, and light emission. In quantum mechanics, a photon is the smallest unit of energy, and energy E is proportional to the Planck constant h and the frequency v of light. It's expressed as E equals hv. Based on this, the shorter the wavelength of the photon, the higher the energy, and the longer the wavelength, the lower the energy. One of Einstein's papers that won the Nobel Prize is the photoelectric effect, published in 1905. This theory proves that light has properties as particles, and based on this, it is an important discovery that has played a major role in the development of modern quantum mechanics. The photoelectric effect is a phenomenon in which light emits electrons when it shoots light on a metal surface. Einstein described this phenomenon as an electron escaping from an atom when a light particle, photon, collides an electron in a metal atom and transfers energy above a certain threshold. These theories shocked physicists, and the fact that light has the properties of particles, not waves, was a revolutionary discovery that overturned traditional physical theories. This theory also played a major role in the development of modern quantum mechanics and was instrumental in explaining one of the key concepts of quantum mechanics, quantization. After all, Einstein's photoelectric effect theory was one of the revolutionary discoveries in physics, which, along with the development of quantum mechanics, greatly influenced the development of modern physics. Theory also played an important role in the development of new technologies in the electrical and optical fields, which became the basis for the development of modern science and technology. Neutrinos are not faster than light. In fact, neutrinos move much slower than light. There may be a misunderstanding that neutrinos move faster than light because they have a mass much larger than light, but do not have electric charges, so they do not have resistance from electromagnetic force. However, neutrinos interact not by electromagnetic force but by gravitational and weak forces, and their speed is very slow compared to the speed of light, 299,792,458 meters per second. Neutrinos typically occur in collisions of moving atomic nuclei at very high speeds, and are also observed in supernova explosions, a powerful explosion occurring in space. Neutrinos have different properties than electromagnetic waves, and by studying them, they help us understand the origin and structure of the universe. Neutrinos, unlike light, can generally pass through matter. This is because neutrinos do not interact with electromagnetic forces. Because light is an electromagnetic wave, it interacts with matter and causes absorption, reflection, and refraction. However, this interaction does not occur because neutrinos are not electromagnetic waves. Thus, neutrinos travel linearly without much resistance as they pass through the material. But neutrinos can also interact with some materials, especially when they collide with nuclei. Through these interactions, neutrinos are used to study detailed structures and operating principles inside atomic nuclei. Neutrinos also play a very important role in the universe, and they also make a significant contribution to space exploration and space physics research. Gravitational waves do not propagate at the same speed as the speed of light. Gravitational waves are a type of vibrating gravitational field in which the space itself vibrates and propagates in the form of wavelengths. These gravitational field vibrations propagate at very high speeds, but this speed is nothing like the speed of light. Gravity waves propagate at a much slower speed than light, but the speed of gravity waves depends on the frequency of the wave's vibration. For example, gravitational waves with higher vibration frequencies propagate at higher speeds. Gravitational waves are physical concepts that differ from the speed of light and play an important role in the study of the structure and evolution of the universe. The technology to detect gravitational waves is currently developing, which can be used to explore important phenomena in the universe.